Okay, correction video, opportunity number 4. Last one didn't record right. On the original corrections, at the very end, there was an algebra solving mistake that needed to be fixed. Nate found that. Thanks, Nate. So we're finding the closest distance between a point and a function. So if you sketch the function, sketch the point, you can see there's multiple different distances here. We got to write an expression for the distance so we can minimize that. Take the derivative set equal to 0. So I want to write an expression for a generic point, a general point, x7 minus x squared. That's just xy. Just like every other optimization problem, you start out by writing an expression and then you put it all in one variable. So the distance formula is x minus x, so our specific x and our general x, and y minus y. So our y minus y is 3 minus x squared. When you square that, you get 9 minus 6x squared plus x to the fourth. When you square x, you get x squared. So our actual expression for any distance, any given x value is right there. So we're going to minimize that. We need to take the derivative. It's going to be a chain rule, derivative of the outside. So we're to the negative 1/2, which means we're in a fraction, times the derivative of the inside, which is 4x to the third minus 10x. Rewrite this as a fraction and set it equal to 0. This is never going to be positive, or negative, because we're x to the fourth, square root of that, always going to be positive. So the only thing we have to worry about is the numerator. This is where the error happened, I think, on the solving on the other video. So hopefully you caught it too. But basically I'm setting that 4x to the third minus 10x equal to 0, factoring out a 2x, and we get 3 possible critical numbers. And I say possible critical numbers because you do not assume that the critical numbers are maxes or mins until you test them. So we got to test in case these could all be maximum distance. We got to see if they're min, neither, whatever. Okay, so we set up our intervals just like we did before, just like you're finding increasing and decreasing. Negative infinity to negative radical 5/2, negative radical 5/2 is 0, 0 to radical 5/2, radical 5/2 to infinity. Again, you're going to plug stuff back into the derivative. The only place you have to worry about is the numerator because the denominator is always positive. So just picking a number like negative 10, if you plug that in here, you get a negative number and a positive number. You can quickly see that becomes pretty negative pretty fast. And then you just pick your way through. I think I use negative 1. If you use 1 here, that gives you a negative. 4 minus 10 is negative. So you always have to test for maxes and mins. So the thing that happens that weird is at 0, you get 0 up here. And so it's a maximum, but it's kind of a strange maximum because really there's not a maximum if you keep going on forever. Okay, so we keep working our way down. Since these are mins, the last part of the question is plug in to find out the y coordinates. So back up here, plug into the original equation. 7 minus radical 5/2 squared is the same as 7 minus 5/2. So both of these are at the same place, somewhere over off to the side there. Hopefully this time it works.